Breaking Boundaries, the mind-blowing discovery of the black hole. The concept of black holes began in the 18th century with British scientist John Mitchell, who proposed the idea of a dark star in 1783. He suggested that if a star were massive enough and its gravity strong enough, not even light could escape, making it invisible to observers. Although this was a purely speculative idea, without any observational evidence, it laid the foundation for future scientific theories. The real breakthrough came with Albert Einstein's theory of general relativity in 1915. Einstein's theory proposed the idea that massive objects could warp the fabric of space and time, which led to the theoretical prediction of black holes. In 1916, Karl Schwarzschild applied Einstein's equation to describe the gravitational field around a compact massive object, predicting the existence of what we now call a black hole. After many years, the physical proof of black holes came to existence. With the development of research in space, the famous scientist Stephen Hawking was able to produce the first evidence of existing black holes. However, before the famous scientist Stephen Hawking, the world misunderstood or ignored the theory of black holes in space. However, his discovery of these black holes have transformed our understanding of space and time, revealing the limits of physics, challenging our views of reality, and creating a greater responsibility of science and astronomy. The discovery of black holes is one of the most thrilling and mind-bending moments in the history of human exploration. It is a journey that starts with abstract math and a bold theory, then takes us to the unknown reaches of space, challenging everything we thought we knew about space. From Einstein's groundbreaking theory of general relativity to the moment we finally captured the first ever image of a black hole, the path to understanding these mysterious objects is about human curiosity and creativity as it is about science. Black holes force us to rethink time, space, and gravity, pushing the boundaries of our imagination and our technology. As we continue deeper into these giants, we uncover not only the secrets of black holes themselves, but also new insights on workings of the universe. The discovery of black holes is a testament with our endless desire to explore, to question, and to understand the deepest mysteries of reality. With a huge role played by the famous Stephen Hawking, the work and effort discovering such a massive quantity of cosmos took great time and gratitude. Eventually, the work was done, and the black hole was finally discovered. Chicago has strong connections to black hole research, primarily through the University of Chicago and its affiliated institutions. One of the most significant contributions came from Samurayan Chandrasekhar, an astrophysicist who, while at the University of Chicago in the 1930s, developed key theories on stellar evolution that laid the groundwork for understanding black holes. He demonstrated that stars were masses above certain threshold which could collapse into what we now recognize as black holes, helping shape our understanding of these mysterious objects forming. Additionally, the Fermilab in Batavia, Illinois, has contributed to astrophysics and black hole research, particularly the study of high-energy particles and extreme conditions in which black holes exist. The University of Chicago's Department of Astronomy and Astrophysics has also been a leader in black hole studies, exploring topics such as supermassive black holes and their role in the galaxy formation. While Chicago-based institutions weren't directly involved in capturing the first image of the black hole in 2019, the scientific community has made crucial contributions to our theoretical and observational understanding of black holes. The early discoveries of the black hole date back even to the early 1800s. With development in technology, the telescope was improved and astronomers would finally get a closer look at what we call our universe. After John Mitchell's time in the early 1800s, Einstein took research from past scientists, astronomers, and many more famous discoveries beforehand. These include Isaac Newton's discovery of gravity. After connecting the dots, Einstein was able to create a theory of general relativity, which finally laid the foundation for future generations of scientists and astronomers. With many other contributions and discoveries, foundations were laid for finally finding a black hole, taking us to the next step of the future. With the Hubble telescope, humans were able to reach the next horizon and take physical evidence of a black hole. Black holes might seem far away, but they actually have an impact on our lives in ways we don't always notice. They can bend space and time, which was proven by Einstein's theory of general relativity. For example, GPS satellites need to take this into account, or they would be way off. If scientists didn't understand black holes and how gravity works, our phones and navigation systems wouldn't be as accurate. In 2019, scientists captured the first ever image of a black hole, which was a huge breakthrough. Studying black holes helps scientists learn about how space works and how it can lead to new discoveries in science and technology. Even though black holes don't directly affect our everyday lives, their study helps improve things like communication, space exploration, and studying the universe better. Black holes might seem mysterious, faraway objects, but studying them can actually help us in many ways. First, by understanding how black holes work, scientists can learn more about gravity, space, and time, which are key to many modern technologies. For example, GPS systems rely on accurate measurements of time and space, and without understanding how gravity affects time, those systems wouldn't work properly. Additionally, black holes help us test ideas in physics that can't be tested anywhere else, like how quantum mechanics and general relativity interact. This could lead to new breakthroughs in technology and even medicine. Research into black holes pushes the development of supercomputers, which can help with everything from weather predictions to solving complex problems in other areas of science. So, while black holes might seem out of reach, studying them can lead to advancements that improve our everyday lives. Black holes are amongst the most mysterious cosmic objects, much studied and not fully understood. These objects aren't really a wormhole or a hole that you've seen in movies. They're huge concentrations of matter packed into very tiny spaces. A black hole is so dense that gravity beneath its surface, the event horizon, is strong enough that nothing, not even light, can escape. The event horizon isn't a surface like Earth or even suns. It is a boundary that contains all matter that makes up a black hole. There is much we don't know about black holes, like what matter looks inside their event horizons. However, there is a lot that scientists do know about black holes. Also, a black hole is always made from a huge amount of mass colliding or merging, including two stars colliding. Depending on the mass, it will either make a black hole or a supernova. Black holes are also formed in the opposite way, otherwise known as when a star runs out of fuel and releases all of its gas, creating a magnificent blast of colors. But with this mass and black hole is formed, the black hole consists of a variety of properties and is almost indestructible. Historical development of the black hole theory. Initially, black holes were the theoretical idea, with Einstein's general relativity proving the first solid foundation. Yet, for decades, they remained distant from direct observation. In the 1960s, astronomers began to gather indirect evidence, like the discovery of Cygnus X-1, which hinted at the existence of black holes. However, it was Stephen Hawking's work in the 1970s that truly changed the game. He introduced the idea that black holes aren't just gravitational traps, but can emit radiation, now known as Hawking radiation, which challenged earlier perceptions of and linked black holes to quantum mechanics, a field previously thought to be incompatible with relativity. Overall, there are many ways the black hole can help us discover the horizon of space, creating a boundary between right and wrong. Even though we are so different and distant, they affect us so much.